Last lesson we learned about identifying arithmetic and geometric sequences. Today we're going to focus only on arithmetic sequences. So where does the equation for arithmetic sequences come from? It looks a lot like point-slope form. Point-slope form, if you remember, is y minus y1 equals m times x minus x1. From the graphs in lesson 10.1, we found that the slope of the graph of an arithmetic sequence is the same as the common difference which is a little more obvious when you line up the equations. So let me show you what I'm talking about. This is the formula for finding the nth term of an arithmetic sequence. And I'm going to write the d in front of the parentheses. And then the point-slope formula looks like this. Now I'm going to move y1 to the other side and put it in front. So now everything seems to line up. You can think of y as an. You can think of x as n. And the slope and the common difference are also lined up. We also know the first term is a1, so a point on my graph would be. Now try to recall what we did during the 10.1 lesson. For the first term, we graphed 1, comma, and whatever that first term was. So whatever a1 was. And knowing point slope, we know that x1, y1 is a point on the graph. So what lines up with x1, y1? 1, a1. Filling in the point slope form would give us, so we're going to plug this point into the point slope form equation. So that gives us, so we've already established that y is like an. y1 is the y-coordinate of a point we know, so y1 would be a1. We said that the slope m is the common difference d. We said that x is like n. And x1 is the x-coordinate of a point we know, so in this case 1. And now solving for an, adding a1 to the other side. We have the formula that we were given. Okay, so that's how you derive the arithmetic sequence formula. Alright, so we're going to use this formula quite a bit now. Okay, find the indicated term of each sequence. So for number 1, looks like we want to find A73. So A1, we plug in 56 plus plugging in 13 for D times N is 73. Using a calculator, 56 plus 13 times 72 is 992. Okay, for the next one, we're finding A19. Looks like A1 is 16. We have to do some math to figure out what D is. To find D, you always take the second number minus the first, once you're sure that it's arithmetic, and they tell us it's arithmetic in the directions. So for this problem, D is 16. And then times n minus 1, n is 19. Remember, n is the subscript there. So this is going to equal 16 plus 16 times 18. Which equals 304. For number 3, plug into the same formula. So on A9 equals -4 plus D times n minus 1. Okay, number 4, we're finding A20. AN equals A1 plus D times n minus 1. Negative 137. Okay. We can use the same equation to write an equation for the nth term. So we're going to use the same formula. AN equals A1 plus D times n minus 1. All we have to do is find A1 and D and then simplify. So A1 is 64. To find D, take the second number, subtract the first number, so D is 14, and now we plug in AN. We don't know. We're actually trying to find a formula for that, so don't plug into AN. A1 is 64 plus D is 14 times n minus 1. If you are writing the equation, your final answer should have AN and n still in it. So don't plug in for AN, don't plug in for n. 64 plus 14n minus 14. AN equals 14n plus 50. Okay, D equals negative 323 minus a negative becomes plus 416. So for this one, D equals 93. So now we plug in. We don't plug in for AN. We do plug in for A1. We do plug in for D. We don't plug in for N. So our final answer for number 6 is AN equals 93N minus 509, it looks like. Yeah. Okay, for number 7, looks like we're doing the same thing, except now we're given some different information. Okay, so we know A3 is -6 and D equals 9. So first thing we're going to do is plug into this formula to find the missing information, which looks like N. Okay, so we can temporarily plug this in for AN. So the third term is -6. We don't know A1. We do know D. And remember, I plugged in A3. So for now, I could plug in 3 for N. And I'm only doing this to find A1. -6 equals A1 plus, okay, 3 minus 1 is 2. 9 times 2 is 18. Subtract 18. -24 equals A1. So now that I know A1, I could plug back into this formula, but I'm not going to plug in A3. I'm using this to find a formula for AN. So AN equals, A1 is -24 plus 9 times N minus 1. AN equals -24 plus 9N minus 9. AN equals 9N minus 33. Okay, so let's see if you remember the process. So first you pretend that's the last term, and you use that to find A1. So we plug in 12. We know D is 8. And we plugged in 12, which is the 6th number in the sequence. Six minus 1 is 5. 5 times 8 is 40. Subtract 40 from both sides. -28 equals A1. So now plug back into the formula. Leave AN and N alone, because we just want a general formula. AN equals -28 plus 8 times N minus 1. AN equals -28 plus 8N minus 8. AN equals 8N minus 36. Okay, sometimes you are given 2 terms of a sequence, but they are not consecutive terms of the sequence. The terms between any 2 non-consecutive terms of an arithmetic sequence are called arithmetic means. Okay, so I'm going to show you 2 ways to do problems like 9 and 10. I'll show you the textbook's way for number 9. So let me write the formula first. So they plug in the last term for AN, and then the first term for A1. We don't know what D is yet. And then to find N, you just count. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. 32 is the 8th term in the list. So then you use this to solve for D. 32 minus 235 is negative 203. Divide both sides by 7 and you get D equals negative 27. No, negative 29. Okay, so then to insert these geometric means, you subtract 29 and you get 206. Subtract 29 again, you get 177. Subtract 29 again, you get 148. 148 minus 29 is 119. 119 minus 29 is 90. 90 minus 29 is 61. And 61 minus 29 is 32. So I actually prefer a different method to find D. Okay, so my method is count how many jumps it takes to get from the first number to the last number. So 1, 2, 3, 4. 4 jumps to get from 41 to 27. So each jump is a common difference, 4D, and the distance traveled, you take the last number minus the first number. So 4D equals 24. So D equals 6. And now you just add 6 to each term. So the answer for this one will be 17 plus 6 is 23. Add 6 again would be 29. Add 6 again would be 35. And if we add 6 again, we get the 41 that we would want. So that's the answer. Okay, last problem. Find 5 arithmetic means between negative 18 and 36. So this is the same as numbers 9 and 10, just written differently. So there are 5 numbers between negative 18 and 36, and we're told that it's arithmetic, so we count how many jumps there are. 1, 2, 3, 4, 5, 6. It's always going to be one more than the number of arithmetic means. So 6 common differences takes us from 36. Actually, it takes us from negative 18 to 36. But you want to subtract the last number minus the first number. So 6D equals 36 plus 18 is 54. D equals 9, so we're going to add 9. So adding 9, we get negative 9, 0, 9, 18, 27, and if we add 9 again, it takes us to 36. So these are our answers here.